Using the chain rule. In this lesson we'll examine a concept that is difficult for some to grasp in AB calculus, and that's how to use the chain rule. But it really isn't that difficult, and I hope that this lesson can get that across. Here's one formatted view of the chain rule. Using this version we can determine the derivative of a composition of functions. We have d dx, or the derivative with respect to x, of f of g of x equals f prime of g of x times g prime of x. Maybe the most challenging part of applying the chain rule is recognizing the need for its use. If we had a function to differentiate like f of x equals sine x, y equals e to the x, or g of x equals log x, we would not need the chain rule to find the derivative of these functions. Let's contrast these three examples on the left of not needing the chain rule with the same functions, but with another expression in place of x. These functions on the right: f of x equals sine 2x, y equals e to the power of 3x plus 1, and g of x equals the log of quantity 5x squared minus 2x, will require the chain rule because they are compositions of functions. And then what we have, what I call the black box version of the chain rule. This version is best applied when we can start off using the power rule to differentiate. And it's d dx, or the derivative with respect to x, of u to the n power equals n times u to the quantity n minus 1 times u prime. And for this application, a function like f of x equals 4x cubed would not need the use of the chain rule, whereas this function f of x equals 4 times quantity x plus 2 cubed would need to use the chain rule to differentiate. Well, we really could differentiate this one without using the chain rule, but the chain rule makes it a whole lot easier. I call this second method the black box version because it's as if the u is a black box. We exercise the chain rule around it using the power rule, ignoring what's inside the black box while we apply the rule to the layer outside of that black box. Let's look at this problem. Differentiate the following function: f of x equals quantity x cubed plus 7 raised to the third power. We're going to use this version, again what I call the black box method, and I call it the black box version because it's as if this cubic binomial x cubed plus 7 is u. So the rule's applied, ignoring what's inside the box. I made the box a little transparent to remind us of what's inside. According to this method, we apply the power rule to the exponent outside our black box. Note that the exponent of the item we want to differentiate using the chain rule, we use that value, n, to multiply out in front of the u, or black box. And that exponent then becomes n minus 1. So this power of 3 above and to the right of our black box will come out in front of our black box, and bringing it down according to the chain rule, we have f prime of x equals 3 times our black box, and our black box is now to the power of 2, which we got by taking 3 minus 1. Now we have our black box in two places. Now we need to take the derivative of this second black box on the right according to the chain rule, which is u prime. And we use the power rule and apply it to differentiate what's inside that second black box, so we bring that 3 in front of the x variable, so that becomes 3 times our black box times 3 times x squared. The 7 goes away because it's 7x to the 0 power, which makes the derivative of 7 equal to 0. Now we can take away that first black box, so we have 3 times quantity x cubed plus 7 squared times 3x squared. We can multiply the 3 times the 3x squared to give us f prime of x equals 9x squared times quantity x cubed plus 7 squared. And we can box in our correct answer. To solve this problem, we could have, without the use of the chain rule, multiplied out, then differentiated each of the several terms. The work involved using the chain rule saved us quite a bit of work with fewer differentiations to make. It would have saved us even more than that for higher powers, where not using the chain rule could result in lengthy multi-term differentiations. Let's look at another problem. Find the derivative of the following function. We have y equals cosine x squared. Here we bring back our rule for reference. For this one we don't use the one with the u because that has a specialized case of the power rule. This is in the form of a composition of functions. The cosine is the f and the x squared, the g, in this composition. So the first thing we'll do is take the f prime of g of x here encircled in blue, and that would be y prime equals negative sine x squared g prime of x. And since g of x is x squared, using the power rule, g prime of x equals 2x. So that becomes y prime equals negative sine x squared 2x. And we can bring the 2x out front to be written as y prime equals negative 2x sine x squared, which we box in as our correct answer. Let's look at this problem. This one will ratchet up the complexity a little. We have g of x equals x cubed square root of quantity 2x plus 1. The square root of quantity 2x plus 1 is really a composition of functions. But this x cubed out front will require us to use in conjunction the product rule. And here's the product rule. Fg prime equals f prime g plus fg prime. And in employing the product rule, we'll have x cubed be the f, and we'll have the square root of quantity 2x plus 1 be the g. And for f prime can be found using the power rule to be f prime equals 3x squared. But to find g prime, we need to use the chain rule. And to use the chain rule, we'll rewrite quantity square root of 2x plus 1 from radical form to exponential form. So the square root of quantity 2x plus 1 is quantity 2x plus 1 to the 1/2 power. And using the chain rule, we will have g prime equals 1/2 quantity 2x plus 1 to the negative 1/2 power times the derivative of 2x plus 1, which is 2. And going back to radical form, that becomes g prime equals 2 over 2 times the square root of quantity 2x plus 1. And then 2 over 2 cancel to equal 1. So that becomes g prime equals 1 over the square root of quantity 2x plus 1. So now we'll take the f and f prime with the g and the g prime and put it all together to find our answer. So one piece at a time, we have g prime of x equals 3x squared times the square root of quantity 2x plus 1 plus x cubed times 1 over the square root of quantity 2x plus 1. And factoring out x squared, our answer becomes x squared open parentheses 3 times the square root of quantity 2x plus x over the square root of quantity 2x plus 1, close parentheses. And we box in our answer is correct. Yes, that was a bit of work, but it shouldn't have been too bad combining our knowledge of the product rule and the chain rule. This has been Using the Chain Rule. Thanks for viewing.